So let's talk geometric sequence. So when you drop a ball, it never rebounds to the height from which you dropped it. You've seen that before, right? Suppose a ball is dropped from a height of 3 feet. So here's the first one, and dropped from a height of 3 feet. And each time it falls, it rebounds to 60% of the height. So if I were to start with 3, and I multiply that by what? 0.6, right? 0.6. I would get a height of 1.8. Right? Why would it not be 2.8? Think about that logically. Because 50% of 3 is 1.5. So it's got to be a little bit more than 50%. Good job, Brian. Yes. Okay, so now I would take 60% of 1.8, right? So 1.8 times 60% equals, and I would get 1.08. And then if I put in 1.08 and I applied 0.6, I would get 0.84. Let me guess, you're using a calculator. Okay, what do you notice? It's not a constant rate, right?
No. It's a rate of 0.6.
It's decreasing, it's decaying.
It's decaying. Excellent. What kind of graph is it? Exponential decay. Ding, ding, ding. Right? It's an exponential graph. Do you guys remember? Big bonus. What's the formula for exponential decay?
Oh, A to the something.
A to the?
Something.
Yeah, you guys realize you have a quarterfinal coming, right?
I'll know by that.
Okay. Exponential function, A times the base to the x. Keep that in mind. Got it? Okay. Compare and contrast. Okay, so this is a geometric sequence. Okay, so now we're going to look at how a geometric sequence compares to an arithmetic sequence. So an arithmetic sequence, okay, tell me, what makes this an arithmetic sequence? There's, what is the constant amount? Plus 7, plus 7. So what is a sub 1? And what is d? What is d? What do we call that? The common difference. That's our constant, right? And what's the common difference of this one? 7. Common difference is 7. What about this geometric sequence? Good. Some of you would say divide by 3 or multiply by 1/3. How did I get there? Okay, this is how I do it in my mind. Okay, to get from 36 to 12, let's divide. You take the second number, divide it by the first number, and you get 1/3. But Mrs. Muller, what if I forget to take the second number and divide it by the first number? What if I do 36 divided by 12? What would you get? 3. You know what you do? You go back and you say, okay, does 36 times 3 make 12? No, it doesn't, right? So it must be the inverse of that, 36 times 1/3. And it'll work like that no matter what you do. Make sense? Why it would be that way?
Yeah.
Evan? I'm sorry? Continue? Oh, I don't think you've ever done that. Right? Yes! Okay. A to the 1 is what? 36. What do you think R is?
1/3.
Well, you would think it's rate, and you can kind of look at it as rate, but you're right? But it's the ratio. Okay? The common ratio. I feel like I say that way too weird. Ratio. Like I'm putting too much emphasis. Too much ratio. So my common ratio for this problem is 1/3. How are we doing so far? Great? Okay. I can. Okay, so what is the common ratio of this one? Tell me. Put in a calculator, tell me. Do it on your paper. What is R?
There's times a decimal.
It's taking me this long for somebody to tell me what. 2.5. Thank you. What about this one?
1/2.
Negative 1/2.
I always close.
Right? About this one?
Some oblong number.
1/3.
Is it 1/3?
Yeah.
Did you do it?
Yeah.
I think so.
Okay. All right, what does the graph look like? So, we already did this kind of, right? The first term is 1. The second term is 2. But then it starts to jump, right? The third term is 4. The fourth term is 8. The fifth, right? You see that? Whoa.
That's a nice one.
No. All right. How do I find the nth term? So what is the 7th term in this sequence? You guys work on this. This is not review because, but you say it is kind of like review because it's just like what? What we just did. What did we just do? Problems. We did an arithmetic sequence, right? This is a geometric sequence. There's going to be a formula. I've already given you a hint. It looks what? What does it look like? It looks exponential. There's a hint. I'm going to take the time for you guys to try and derive this, so take the time. Okay. Kevin, where'd you start? First of all, what is the 7th? So we have 1, 2, 3, 4, 5, 6, 7. We'll make it a little bigger. I don't know if that's...
It is right for smaller.
182.25?
Yeah.
Okay.
Okay, so I found out that, so it's, given the next number, you multiply this number by 1.5.
So to get from here to here, I have to multiply by 3/2? Okay.
And then, yeah, I did that over.
You did that over and over, and you got 182.25. Awesome. Okay, Evan, do you think you have an equation? It's in the orange box, and you're just waiting for it. Okay. Think exponential. Matthew's thinking. So if I want to know a to the 7th term, right, what would I start with? Hint. What would I start? Right? I would start with 16. What do you apply to 16? The ratio. Right? Same thing. What's this piece? To the what? How do I get to the 7th term? To the 7, what do you get? Put in a calculator, what do you get?
I think I should, you know.
What'd you get? How much?
4, 5.
Not. What'd you get?
4, 5, 8, 6, 4, 7, 1, 4.
Okay, try one below.
Oh, it's minus 1, looking at it. It's the old formula.
The old formula. The old formula. Try that.
I got 1, 18, 37.
Okay, are we good? There's your equation. You're going to see it in a second here because we got to run. Compare and contrast for me. Here's the one you know. Here's the one we're doing today. What's the same? There's no D. There is a D. It's just called something different, Evan. What's it called? It's called, this is called the common difference. This is called the common ratio.
Because the ratio is like a multiple.
Let's do this. Hey, look at this. How does that look the same? Whoa, does that blow your mind or what? You don't see it? You don't see it? It's right there. What's the base? That common ratio, right? Are we good? Let's do one. How do I find the nth term? What is the 30th term in this sequence? So do that one for me, guys. All right, we're not going to get through this lesson, but look at where we're going. We're not going to even touch that. So you plug, what do you do with these? You write down the formula, plug whatever you've got in, right? It's the same thing as arithmetic sequence, only it's geometric sequence. It's just, right? No, you don't even have to use the arithmetic. We're just using the geometric today. That's it.
Can you plug it in?
No, one formula. Well, I will. What does a geometric mean? Do you guys remember that? It's the middle numbers, right? So arithmetic means, I need it quiet. In order to get these numbers, you'd somehow, from what they give you, you would find R and apply it to the first term, get that one, then apply it to the second term and get that one, right? Okay. So I'm not too worried about not getting through the lesson because it's just like arithmetic, it's just a different formula. So let's do this last one. Try this one right here. Find the 30th term. I'm not going to finish it. Yeah, exactly. It'll be online. I'm recording. So try this one. I'll pause. All right, so we have to find a to the, what? No. The 30th, I need a to the 1, which is 1/8, times my ratio, which is 2. How to get it? 1/4 divided by 1/8 is actually 1/4 times 8/1, which is 2. Then I go back and say, does 1/8 times 2 equal 1/4? It does. It does. Then I know I did it right. Right? Yeah. Okay. Wow, I was enthusiastic. I got your stuff. Okay. 2 to the what? 30 minus 1. And what'd you guys get? 67,108,864. Good. Did you guys try this one? What's R? -2. This answer is -4,096. Have a great weekend, you guys. Thank you.